Hello, my name is Corey Gagel. I'm a student at Goldsmiths, University of London. I'm currently working towards a master's degree in computer games and entertainment, and what I have here is a Lindenmayer Systems program, or L Systems program, that I developed for the maths and graphics portion of that degree. What I'm going to show off are, first off, go ahead and get one up, each of the individual trees that we had were as examples for the sheet that was given to us to implement. Also, I'm going to first show the basic requirements. What were the basic requirements? One was to read the configuration file containing the L system parameters. I've actually already done that by actually loading up this tree right here. It loaded up all the L system parameters, displayed the tree for the user to see. I also need to demonstrate that the L system is able to iterate between each of the different iterations. So as you can see, that is what's happening here as I'm incrementing those iterations and is doing as see fit. Now, other additional requirements. We need to hotkey at least 4 different configuration files. As I actually switch between each L system, that is what it's doing. It is actually reading each L system from a different configuration file and loading it up for the user to see. The other thing we need is we need to increment and decrement the L system parameters, which are then used to recreate the L system model that you see here. Now, one of them is incrementing and decrementing. Another one is the angle that we can do here. And what I've also done is put in some where you can zoom in, zoom out. It's camera controls. Move the sides, move up and down, and also tilt down and tilt up and tilt to the sides to basically get whatever view you want of that L system. Now this is tree A in the example, and I'll just quickly go through each of the 6 trees, and then I'll go through the bonus features that I implemented that aren't readily apparent right now. Some of the bonus features were to do this in 3D using the Octet framework that was developed by Andy Thomason, and to also color it in 3D, which obviously you can see I've done. This is the second tree actually that you on the worksheet, tree B, and incrementing, decrementing, closing the angle, opening the angle, and being able to zoom in on it are just some of the features that we are able to do. Now, this is tree number 3. It gets kind of wild and hairy, as you can see. You can close it, open it, and again we can zoom in on individual components as we see fit with the camera. So those are the 3 simple trees. Now the next ones actually I have implemented in 3D. So I changed the original formulas from the worksheet. This is actually 3D representation of tree D. Here you go, incrementing, decrementing, closing the angle, opening the angle, and of course we're able to actually use the camera to zoom in and out and see as we see fit. I'm twirling the tree as you see, just so then that way you can just sit back and look at it and you can see every angle of the tree without actually doing anything with the camera controls. This is tree E. Again, 3D representation, incrementing, decrementing, closing the angle, opening the angle. Alright, very good. Now, this is the final tree that was a demonstration, tree F. It's in 2D representation, incrementing, decrementing, closing the angle, opening the angle, and there we go, turning it so that we can see it in all its majesty. Now, there were a couple of bonus features. I mentioned the 3D and coloring. That was part of it. The other thing that was also rendered in there was also leaves, which was not rendered into this. What I did do, though, is render some more L systems instead, focused on that so I can get an idea of how that worked. Like one of them is this pattern. Not much of a bonus feature. It's just all I did was I was able to actually implement this or put this into a configuration file and not do anything to the program itself, and it ran this L system and displayed it as you see here. So just a check for me to show that it is working properly. Now the next one, though, is more interesting. This is a stochastic L system. The stochastic L system will randomly generate the branches depending on a random number or percentage as it goes through. Now, as you see, it is able to be incremented, decremented. You can close and open the angle just like all the other ones and zoom in as you see fit. The difference between this one is every time you load it and as you see increment and decrement the tree itself, it changes. It's never the same. That's because of the random feature, and that's the part of the stochastic. As you see, this is a 2D representation in 2D L system represented in 3D. as some of the others are. The last one, another 2D L system rendered in 3D, is a context sensitive one. Now, what we have here is, as you can see, it goes in, and the top branch tends to grow faster than all the other ones. And that is by design. It actually is supposed to intelligently show, oh yeah, it's going to grow that way. It kind of makes this vine that you go along. And as you can see, as the branches go up, the higher branches actually are more developed than the lower branches, just by a little bit, maybe one iteration, so to speak, or whatnot. And eventually what will happen is this top branch will eventually start to bud its own vine, just like this other one did, and will start to loop on along the other way. So I'm not going to go that far because it can take a while sometimes, but as you see, this was actually a bonus feature that I wanted to put in to get a better understanding of L systems and actually get a little bit more versatile program out there. This is my L systems program. Hope you enjoyed it. Thank you very much.